Alright, so now we're going to go into defining our linked list class. And to do this, what I'm going to start with is I'm going to ask, hey, I first need a notion of an empty linked list. So what should I do for that? Well, one thing you need to know is that the empty linked list is shared among every single linked list out there. So remember from our car example, if we want something to be shared between every single car out there, we should make that a class attribute like we did with the number of wheels in the car class. So like that, I'm going to make the notion of an empty linked list a car. Not a car, a class attribute. Okay, so this is basically going to be bound to something that's empty, and I'm going to use a tuple in this case because the reason I use a tuple is that it's immutable, because an empty linked list shouldn't change at any point. The notion of an empty linked list, it would be terrible. Like everything would break if my empty linked list suddenly had like an element in it. That would be terrible. So we don't want that. Okay, so now we can go about defining the constructor. And when we define the constructor, the constructor should take in a first element, and it also should take whatever is the rest of the linked list. And remember from our example of looking at the end, so let me go back to that example real quick. So hold on. So right here, if we didn't pass in a second argument, it ended up being just empty. So notice that. So how do we do that? Well, what we can do is we can make rest have a default argument of empty. And remember with default arguments, we can pass in an argument if we want, but if we don't pass in an argument, it'll just be whatever we gave it. So then what we can do is we know self.first, so we want to make attributes now, and then self.rest equal to rest. Okay, and then what we can also do is we need to have some way of validating whether we got a right linked list, right? Because we can only do things with linked lists if they're actually linked lists. So how do we check if something is actually a linked list? Well, let's go back to the definition. At the end of the day, a linked list is composed of an element, and then the rest of that, so the key thing is to look at the rest of the linked list. It has to be either a linked list or an empty linked list. So that's the key idea. So in this definition, a linked list has a first element. It's either empty, which we're not going to really worry about the empty case because that's just an empty tuple. But if it's actually a part of the linked list class, it has a first element, and the rest has to point to another linked list that could also potentially be empty. So we have to take into account these type of ideas. So how can we do that? Well, first I can basically assert that rest has to be either linked.empty, or it has to be basically it has to be a linked list object. So how do we check that? Well, we can do the instance method, where we can check if our rest is an instance of the linked class. So this is why we went over the assert statement, is operator, and the is instance for this statement. We're also going to see the is operator again. So anyway, now that we have this, let's actually make sure that this works. So hold on. Let's go down here. Okay, so I'm going to interactively run Python, and I'm going to define my own linked list now. Link 2 and link 3. So this is a proper way to define a linked list, and we can get linked.first as being 1. Now, I want to also show you, what if I define, so bad link, I'm going to call it bad link, is equal to, let's say I defined it in a way that doesn't look like a linked list, so something like this. Like link 1 and 2. This doesn't work because the rest of this is not a linked list. Like if we look at it, this has to be a linked list. So this is a bad linked list, and we'll get an assertion error. So that basically tells us, hey, something went wrong. So this is the good thing about assertion errors. They tell you that you did something wrong. Okay, now, if I go, so now, remember, we just need a test. So the link.rest of this is basically link 2 of 3, and the first element of that is 2. And then if I do the same idea, and go one more layer in, link.rest.rest gives me link of 3, and if I do .first to that, I should get 3, and then link.rest. After that, it's just an empty tuple. So this is pretty much the idea of how we're going to work with linked lists. Okay, so now what else do we have as our main goals in the linked list class? So let's check this out. So we want to have some notion of defining the length and defining how we can get items. I'm not going to worry about the repr right now. I'll get back to that. So how do we do that? Well, before I want to implement this type of user abilities of the linked list class, I want to go into how we actually define the length of a linked list in general. So the way I'm going to do that is I'm just going to define a function called length, which we have right here. So the length of the link finds the length of a linked list. And so here are some examples. Pretty straightforward. But how would we define the length of a linked list? Well, one way we can do is we can iterate through a list, and every time we encounter an element, we can basically increment the count. So this is a pretty standard way of defining the length of a linked list. It's an iterative way. So we start with a length of 0. And what we can do is, while it's the case that we're not at the end of the linked list, so how do we do that? Well, we can basically say, while it's the case that link is not link.empty. So this basically says, hey, I don't have a empty linked list as my link. Okay? So and the way we can check that this is a good case to have, if the empty linked list is, so because remember, at the end of this, we're going to return count. So if it is an empty linked list, I know my count should be 0. It shouldn't even execute this while loop. Okay? So then what I'm going to do is every time I encounter an element, so if my link is not empty, I know I'm at some element, I increment the count, and then I also move my way through the linked list. So how do I do that? Well, I make link and I rebind it to the rest of the linked list. So this basically tells me, hey, so in this example right here, for example, I'm going to start at this element, and then I'm going to I count it, and then I go to the rest of it. So that's this linked list right here. And so then I'm going to go to the rest of that, which is this linked list. So now my count is 2, and then once I count this, I get to the empty linked list, which is non-existent, and then I'm done. So I get the count of 3, which is the correct answer. So let's just test this though. So let's do a doc test on this. Yeah, doc test right there. Alright, so that works. Now, the next question is going to be the same question, but we're going to define this function recursively now. And recursion is a great way to work with linked lists because linked lists have a recursive definition. The rest of a linked list is also a linked list. So we can use that to our advantage. So, how do we do things this recursively? Well, think of the simplest possible case. What if we got an empty linked list? Well, so let's take in that case. If the link is link.empty, well, we know for sure that if the length of an empty linked list is just 0. And so now we need to take in that idea of, if it's not an empty linked list, every time we get an element, we basically need to increment it by 1. But we need to do this recursively. So what we know now, the key thing to notice is that there's a natural recursive definition for a length of a linked list. It's that, so if we're at a particular element, it's 1 plus the, so if we're at element, like let's say here, let's say I'm at element 2 here in this linked list. So the length of this linked list, I include this element, which is, so that gives me a length of 1, and I add the length of the rest of the linked list. So that's going to be the definition. So here it's 1 plus 4. Here it's just 1, because it's 1 plus 0. The rest of this linked list is just empty. And then the length of the rest of this linked list, right, if I here, is 2. And then I include the 1 right there. The 1 element, not the value has no impact in the length. It's just how many elements there are. So if I have, my link is not the empty linked list, I know I have a rest attribute, so I just return 1 plus the length recursive of the link.rest. Alright, so let's make sure this works. Oh, what did I do? Return. Oh, this is not a return statement. That's not good. Okay. And it works. So, this is a natural recursive definition of a linked list length. So, again, recursion is very useful when we work with linked lists because of its recursive definition. So, the next question we're going to talk about is, hey, what was our second goal? I mean, our third goal here. We wanted to basically be able to get elements from a linked list. So we should be able to do that in a function as well. So we get the idea of how to do that. So what we can do with the get function is we want to get an item at a particular index. So I'm actually going to define this recursively as well. So there's a natural recursive definition for this too. And it basically, we have to think about what's a good base case. Well, the easiest element to get in a linked list is just the first element, because I just do return link.first, right? Like that gives me the first element. So what does the first element correspond to? Well, that corresponds to if it's the case that the index is 0. So notice that whenever I do these recursive examples, I always think, hey, what's the easiest problem I could solve? Okay, so, but what if it's not the first element? Okay, also, by the way, I'm going to assume that the index is in a good range. So I'm not going to worry about the case where the index is out of bounds. Although it's pretty easy to just define an extra case for that, but I'm just not going to worry about it. I want to basically get, that's a small detail. I want you to understand the large ideas here. So, so basically if the index is not 0, I know it's somewhere in the rest of the linked list that I have to look for my element. So what I can do is I just need to get the element from a particular index in the rest of the linked list. So it's the same problem except smaller, because now I have a smaller linked list and my index. So what I basically have to do is, so let's say I want to get so let's look at this example because it's a little bigger. Let's say I want to get let's say third index of this. So the third index of this is 8. So it should return 8, which is shown right here. Okay? Now, so basically what I can do is I first check if the index is 0. It's not. But basically getting the third index of this linked list is same as getting the second. So if the second element index of this linked list. So notice that if I progress my way through a linked list, my index becomes 1 less. And then if I go again into a linked list, my index is now 1. So the one that I want, the index I want, the element at the index I want is going to basically be 1 less every time I progress through my linked list. So we can naturally get this in a recursive definition by doing this. Return get on my link.rest. So I'm now going to look through the rest of the linked list, and I'm going to decrement my index by 1. So let's test this out. And it works. So again, the key idea, just to make sure that I really hit it home here, is so if we first check the first element to see if the index is 0. So we check if the index is 0, and if it is, we get the first element. And then if it's not 0, we know that it's somewhere in the rest of the linked list. And then once we go to the rest of the linked list, if say we had the third index, we're now looking for the second index because that's the element we want. Okay, so that's how a recursive get function works.